So good morning, good afternoon, and good evening, everyone. Today in the last class we were troubleshooting this parallel to IPSec tunnels. So that will be continued now, and I'll show you what was the issue and what was the fix I did, and then followed by that I will walk you through the PCAP, and also we will do a site-to-site tunnel to see the messages in Cisco devices. And also we will do some kind of a debug in parallel to see some messages. We'll try for it. And followed by that, we have an SSL TLS handshake session. So I will walk you through the steps and procedures to do the pre-configuration to decrypt your traffic in Wireshark. So to give a detailed explanation, I would say today the SSL, we're going to talk about the SSL handshakes, a little bit of whiteboard about SSL and TLS handshake, and then we'll jump into the Wireshark. We'll fire up the Wireshark and we'll see the packets there. We'll see every packet and how it's been exchanged and what are the key parameters we should understand to troubleshoot the SSL and TLS handshake better. And I hope this helps for your SSL and TLS handshakes. Now you know this SSL is deprecated. They call this as a TLS. So TLS is evolved from SSL. It's an old protocol SSL that is deprecated, not used anymore. So still some protocol they name it as SSL, but the version is different. So TLS is actively being used. I think in TLS 1.0 is also deprecated now. So TLS 1.2 and 1.3 are most widely used, and TLS 1.3 is the latest version of TLS. So that's really about today's session. So let me quickly open up this PowerPoint. And before that, we'll continue with the Palo Alto. What we did in last class, we'll continue with that. For that, let me open up the browser once again. One second here, I'm just trying to fix something here. Oh. Okay. Let me reshare again. I'm just trying to log in my remote desktop. So I'm trying to install the Wireshark on this device to do the SSL encryption decryption profile. That's running here. And the files and how to. It's very old, I think, to start this development version. Okay, fine. So let's jump into it. I'm trying to fix this Wireshark here. So very quickly explain to quick recap about the topology. So we got the 30 subnet on the left side. and 40 subnet on the right side. These are two LANs, and we build a tunnel. We build a IPSec tunnel between them. There's an IPSec Site-to-Site VPN. So this is an IPSec tunnel created like this. Yeah. So your encryption actually happens within these two interfaces. So you don't see any encryption here, because in the transport mode, your complete traffic will be tunneled. So we are using the site-to-site VPN. So only this part is tunneled and whole thing is encrypted. And we discussed about this in the previous classes. So this is a quick recap about the topology. So what we had an issue last time is that we don't see this. We had this outside to outside communication, but whereas from the tunnel to tunnel, it is not happening. I'll show you the configuration inside. So we are on 30 subnet. We are on the 30 subnet. It is on the left hand side, Linux one. We are on 30 subnet. Let me make this to differentiate. So this is 30001. And if I go to this policy, security policy, I have a crisscross rule here. If you look at this, I can't make it even more bigger. So if you look at this VPN, so right now we got 3 security profiles, and you see the hit count for the four security policies, right? One is intrazone. That is a packet which tries to talk to each other in the same zone, intrazone. And I had to create one more security policy. It's a VPN. I gave a name as a VPN. It is a user-defined name. You can give anything, but I have a crisscross rule where in the VPN zone, I allowed VPN to outside and outside to VPN. So I should enable both the rules to build my IPsec tunnel. So in the VPN zone, you're going to allow your inside, right? If I open this, I'll show you how exactly I did that. So source zone is VPN and the destination zone is outside. And also you need a zone should be open for VPN and inside. So you can also make a crisscross rule as inside. I will write this. So inside zone, this is VPN. So you can create your crisscross rule like this because this is a source and this is a destination. So your traffic flows between your VPN zone and the inside zone. So you can have a crisscross rule like this on both ends, source and destination. So your traffic goes like this, right? Delete this. So your actual traffic goes like this. It goes to from VPN to inside and your inside to VPN, vice versa. And here the challenge is in 8.1, I don't have this monitor, I think we need a license to see that. So this is a bit of a challenge. Even without the monitor logs, you can still troubleshoot with just an Wireshark. Just with the Wireshark, we can troubleshoot this. This is just a small challenge where you can try this 8.1 because I don't see any monitoring profiles, but why it is failing is something we can find with Wireshark. I'll show you the logs where to capture. And if I go to network on my IPSec tunnel, you see both are green. And if I go back to this tunnel back here on Linux 2, let me open up this Linux 2. If I go to the browser, open up the logs, policies, and if I go to the security policy here, so if I look at this, I mean, this is the rule. If I track this, bit small, you can actually see the hit count. The highest hit count is 55,23,683 packets. And this is the crisscross rule I'm talking about. So you're allowing a traffic within the firewall. You allow a traffic from inside to VPN and VPN to inside because your traffic flows between your inside and VPN zones. So we have to allow this, right? So I have a crisscross rule like this on both firewalls. Inside VPN and VPN inside. So the traffic flows like this, right? It goes from your inside to VPN and VPN to inside, vice versa rule. Both for your ingress and egress traffic, you should have this rule for your IPsec tunnel. So other than that, our IPsec parameters are fine. And you can see the hit counts here, but we don't have a monitor logs. And if we go back to this capture, and also I'll show you the capture, how to do it again. If I go to Linux 1, that's Linux 1. Denying access because you have exhausted the limit. Please close and try again. Just now we opened this. Let me close all these terminals. Yeah. So if I go to this particular PC and then if I see there are two profiles I've created for this. If I go to monitor and if I go to packet capture, I got two capture files. I mean, I have created two capture files. If I open this, we can see the rule inside. So here I want to give any name you can give it, and you have these three options: firewall, receive, and transmit. So I want to capture the traffic for both for me ingress and egress. So I have my profile created for transmit. The stage is transmit is all the egress traffic, the packet which has been sent out from this particular firewall. So you can give something like some substantial value, maybe 10,000 bytes of data. That's something I did. So once I created this profile. I'll show you how to do this. For receive, if you want to do for the receive traffic, you can do it receive, and you can give receive underscore VPN, any name you can give it. And if I can give out 10,000 bytes, here also I can give 10,000 bytes. So it is done. Your packet capture should be on. And if you go to the manage filters, here what you want to exactly filter here. So here I can give something, my ingress traffic, the traffic which is coming in is Ethernet 1/1. Both for ingress and egress. So I can give my tunnel interface. And I can't see encryption, decryption on the LAN interface here. I'm not going to use it. Source, you can give it anything, all zeros. Here you can give all the source. So you have two filters there. And then if you generate your traffic, and as I said, you have to check on both end to see your tunnels, the basic checks. Go to your IPSec tunnel and it is up. And if you go back to your, this is on. If I give if config, this is the T. So I'm going to the other side of the LAN, that is 40,002. I can ping it. So it generates a traffic here. If I go back again to monitor, packet capture, we gave this transmit underscore VPN. I can download this PCAP. It's a pretty big file. And it is loading now. And if I give ISACamp, it's loading here. So let's scroll down. So this is something we did a transmit. So you see this is only it captures the traffic that goes out. So we don't see the So this is a responder response, so it means that the initiator is on the other end. So, and if you see this ISAC camp, it is happening only between the public and public. If you look at this topology, it is between 10 and 100. All your MM1 messages happens. So it's a phase one tunnel. So when it goes to your quick mode, there you will see your phase two tunnel, your actually interesting traffic inside. So that is all purely encrypted. We discussed about this in the previous class. After MM4 and MM5, all your packets are encrypted. So you don't see anything after MM4. So MM5 and MM6 is completely encrypted. That is your quick mode, and all your quick mode traffic you can see in your with your ESP protocol here for the Palo Alto. And we discussed this, the SPA value. From the SPA value you can differentiate. So we just capturing the transmit packet purposely to see, and this is the only the SPA value of the sender, the source, 10.0.0.1 and 100.0.0.1. So when you troubleshoot your problem, you should see your ISACM packets in the Palo Alto, and in the ISACM packets, the expected is you can see only the outer header value. And when you're using your ESP, the whole packet is encrypted. If you open it, you can't see anything. Inside this ESP tunnel, this is your phase two tunnel. There, actually, your interesting traffic talk to each other. So these are all the key things you should troubleshoot when you do a capture. You should see all these packets in your Wireshark, and if you see that, then your communication is happening. Now, it is loading here. It's a pretty big file. So this is just a communication between the gateway and the actual PC, right? And I see some traffic for the TLS. I see the traffic for TCP. This is just a communication between these two, and this is not encrypted here. This is just using a self-signed certificate here to do this, just for information. So your actual traffic, when it hits to when it is heading to this Palo Alto, so here exactly it gets encrypted from this interface Ethernet 1/1 and Ethernet 1/1 on the other side. This is a site-to-site VPN. This is how it works in Palo Alto. The way of implementation and there are certain characters. It is different for the Cisco, and I think for every vendor there is some minor changes, but more most of the basic parameters and the what do you say the basic mechanism of IPsec remains the same. There there will be a slight difference, but most of the IPsec parameters that remains the same. It doesn't change. So if I go back to this receive traffic, if I go back to this Palo Alto, and if I want to take a capture for the ingress traffic, this is egress traffic. And this is the traffic I'm receiving. If I save file, so this is coming from 100.0.0.1. If you see this is 100.0.0.1 coming to 10.0.0.1. And if I give ISEC camp, you should see this. 1, 2, 3, 4, 5, 6. Total 6 main mode messages. We should see that. And then you should also see your ESP packet for it. We didn't capture any ESP. So this is coming from 100.0.0.1 to 10.0.0.1. You can see that. So when you're troubleshooting this helps you to figure out, so do I see the ESP packets and what kind of value I should look into it? And is it properly encrypted or not? So this is how you do a packet capture in the Palo Alto, right? So in Cisco, they say it is an embedded packet capture. There you can do your capture on the device. Also, you can take a TCP dump. That's a different way of doing it. But when the actual communication encryption decryption happens, it is always advised and it is always you should use your device to capture your traffic. You have to take your TCP dump on the device, especially for your IPSec. But for your TLS, you can use either your source or destination to do it. So it's based on the scenario, what you're troubleshooting and working on. So based on that, you have to be more adaptable to change your troubleshooting steps. Then let me quickly take this. Uh, let me quickly take this course content. And one more thing I want to tell you, I missed out one more thing. So in your capture, so if you look at this, the TTL value, right, from source to destination, it says 62. So it is 2 hops away, right? So I got a VIOS and I got a Palo Alto in the middle. So 1, 2. There's 2 hops away. So you from this you can confirm that is it something really your routing is happening or not? Is it properly routed? Is it 2 hops away? Then I should see my TTL decrementing from 64 to 62. And if I go to any ICMP packet here from 30.0.0.2, it's coming back. Just can someone tell me why we see this TTL as 63 between this 40.0.0.1 and 30.0.0.2? We can discuss this in the Q&A. And then what else? These are all the key parameters. When you cover all this, I think you would be able to troubleshoot your IPsec tunnels definitely better. A quick recap about what we discussed. So what are the key parameters we should focus on? For that, let me quickly open up a whiteboard. So what should I see in my IPSec tunnels? There is, I told you it's a phase one, it's a phase two, right? So you define your Diffie Hellman group. So when you're troubleshooting this, is there any mismatch with your Diffie Hellman groups? It should match each other. If you're using your pre-shared key, it should match each other. Since we are not using policy-based VPN, we are using route-based VPN. For Palo Alto, this is site-to-site. Palo Alto PE, Palo Alto. You have to check for your pre-shared key, your key encryption, and hash. As I said, these three parameters are very important. Your key encryption hash that take care your phase one tunnel. And we discussed about this, yeah, MM1 until MM6 messages. You should see all the 6 messages. Then comes your quick mode. So in your quick mode, if it is in an idle state, it is good. Because why it is an idle state? Using this Diffie-Hellman group exchange on both ends, it comes up with a session key. So your new session key will be created based on your lifetime. And if a lifetime example for 1 hour, and after 1 hour, the session key will be created. So most of the time you would see in the Cisco boxes, your quick mode would be in idle state because it is done with the session key creation, right? And your pre-shared key here, the Diffie-Hellman actually carries your secret key that is encrypted using this, and it goes out to the other end. So this is very important theory you should understand behind your IPsec tunnel. And only in your phase two, you know that your interesting traffic, right, all goes inside your phase two, and that is purely encrypted. Because after MM4, MM5 messages, everything is encrypted. Even the phase one, you can't see anything. The phase two is completely encrypted, and here we use a protocol ESP. And here for phase one, we are using ISACAMP. I take a different color. So we use ISACAMP here. So this is how we troubleshoot. So from the Wireshark perspective, what else we should see in the Wireshark perspective? You should see your TTL. You should see your ESP. You should see your SPI value. You should see your ISACAMP packets. This is applicable for Palo Alto. And if you are doing Cisco, you will see all this main mode messages, main mode message 1 to main mode message 6. Then you will also see your quick mode. But here you will see ISACAMP. So here actually you will see your ISACAMP and ESP. You will see only these two in Palo Alto. Whereas you see all the main mode messages, 6 messages, and quick mode message in Cisco. And the troubleshooting part, when you're doing with your Palo Alto, you have to check if your traffic is not, if say for example, if you suspect that my egress traffic is fine. So if you see a traffic from your transmit, when you see a packet capture in the transmit, if you see all your ESP and your ISACAM, but whereas in your receive traffic, if you don't see your ESP and ISACAM, then you should check something on the peer end. Is it your phase one is up? Is it your key encryption hashing matches on both end, right? So it should match on both end. And in Palo Alto, we are using one more, we are using Diffie Hellman twice in the Palo Alto. That's something we discussed, that is perfect forward secrecy. We use this PFS key again in phase two in the Palo Alto. And in the Palo Alto, one more thing, there are multiple ways of doing an IPsec tunnel, but one is if you are using a tunnel interface with an IP address or without an IP address. I used a method without an IP address. The actual flow, the data flow happens, your data plane traffic is going through your VPN tunnels, but we are not using any IP address on it. But if you are using IPsec tunnel with a tunnel interfaces, then you have to pick a common prefix. You should pick your common prefix, right? You should pick a common prefix. Example, if you're taking something like 20001 on one end, the other end should be 20002, and this is tunnel 100, the other end is tunnel 100. You can route your traffic like this. Multiple way of doing it, and I'll show you how we did. We go to network, then if I go to interface, and if I go to tunnel, I didn't assign any IP address on it, but it has to map to the proper security zone, and it should be attached to the proper virtual router. So we are using virtual router 1, so it should be properly attached to the proper virtual router, and you have to define your security zone properly. Other than that, I didn't assign any IP address, but you have to. And one more thing, as I said, you should have 3 rules: inside to outside, outside to inside, then VPN to inside, and inside to VPN. So when you build a rule here, the most important thing you should understand is this: when you allow your traffic back and forth within the Palo Alto, so you should allow your traffic from within the firewall, I'm telling, from inside to VPN, and from your VPN to inside, and your traffic from inside to outside, and then from your outside to inside. Ensure that you have all these rules, otherwise your IPsec tunnel will not work. If you generate your traffic something from inside, and if you're trying to reach something outside, it works. But when you try to ping from outside to inside, if you don't have this rule, it doesn't work when you're doing your VPN testing. So in the beginning, if you're learning, it is always better to have all these 4 rules. This helps you to troubleshoot better, and you can play around with these rules and you can figure out why it is not working. Without the monitoring mode, try to do it with just a Wireshark, and that proves that if you can see your ISEC amp, and if you see your ESP, yep, your connection is good. And if you got something in the middle, it is blocking. From there, you can troubleshoot what you will see in the Wireshark and how do you find a problem, like how we did. Try to ping across, spend some time, and try to learn this lab. Now I will give a quick session for a 15-minute session for a Q&A, and then we'll resume again. Hi everyone. Do you have any questions? Hi Prashant. Do you have any questions?
No, Praveen.
Okay. Asad, Malhar, Miraj, Juan, do you have any questions?
No, Praveen.
Okay.
No, Praveen.
Okay. And then you guys understood how to do this IPSec tunnel, how to troubleshoot, and how to take the packet capture. That's most important. How to take a packet capture in the Palo Alto firewall. If you guys have any questions regarding that, you can ask me. If not, we will jump into the class again. Okay, we'll jump back again. If you have any questions, we have one more Q&A. We will do that. So you can see this, a quick recap. So you got a main mode, set up a secure tunnel. Quick mode defines what traffic to encrypt and start the tunnel. So your actual phase 2 starts on your quick mode. So there are 6 messages exchange. It negotiates encryption key, encryption and hashing. We are using a Diffie-Hellman key. We are using a MD5 hash in this example. And encryption, we are using AES. So it performs an authentication. Your authentication is based on your pre-shared key. So both ends should agree upon the negotiation. Once it is up and running, you will come to your IKE phase 2. It establishes your actual IPSec tunnel, your IP traffic, your data tunnel happens in phase 2. And 3 messages are exchanged here. And you can use an additional Diffie-Hellman exchange for perfect forward secrecy. We have seen that. And it's a fully encrypted communication. You can't see anything inside. So after this, it's completely encrypted. It begins your secure data transfer. That's a whole view of your IPsec tunnel. Then coming back to your SSL. So we'll very quickly we'll do a whiteboard for 5 minutes. We'll jump back to your SSL profile creation and how do we capture the SSL traffic. Yeah. So in the SSL, we know with SSL and without SSL, what is the difference? That's something I want to give a quick background about that. So your actual traffic, we know we are doing this for a very long time. So I don't want to give you much explanations about this part. Say, for example, if I take this is not good. So your TCP, we know three-way handshake happens. And this is layer 4. There are only 2 transports so far. And there is one more that's upcoming that it's being used that's called quick, that is out of topic. So the transports we use mostly used are TCP or UDP. So the TCP, they evolved and they came up with a protocol, like a quick protocol. That's something we are not discussing, but still now the most widely used is TCP for the connection oriented protocol. We know this. And apart from this, this is, as I said, this is layer 4. So when we are going to the upper layer, right? So we don't bother about presentation and everything. We go all the way back to your layer 7. So whatever the protocols we use, say for example, if you are using your HTTP again has a different version as HTTP and HTTP.2. All this comes under your layer 7. But we can't actually see when the connection is happening over the TLS tunnel. Say this is an SSL tunnel that is deprecated again. So all you see is whenever you go to a Google, let me open this. Unable to Wireshark, not able to find in order to PCAP must be installed. Okay, so I will go to this box, Linux boxes. So now let me open this Wireshark. And if I follow this stream, this is between 30001 and 30002. The 3001 is something I have configured in the Palo Alto Ethernet 1/3. I'm trying to do an HTTPS to it. So I get this capture. This is an application data, layer 7. And if I go ahead and if I do whenever I see a packet and I want to see the conversation from the beginning, I have to go to TCP. It's a half broken connection. I don't see the SYN packet. Let me go here. Conversation filter TCP. Okay. So right from here, I see SYNAC hack, my layer 4 communication. Then it sends a client hello and server hello. That's fine. So what I'm trying to say is here you see a lot of application traffic. But if I try to open this SSL, it's telling HTTP over TLS and all your application traffic, including your protocol, is encrypted. We can't see anything. This is how it works. But it is using it is telling it is using HTTP, but it's over TLS, so it is encrypted. So this is an HTTP connection because we open this with HTTPS. Go here, we open this with HTTPS, that is 001, right? And when we are troubleshooting your TLS, when you're troubleshooting your SSL, the base thing what you should know is you should click on your pad icon and it is telling that the connection is not secure. What is the meaning of this? We go to the more information. I give a view certificate. So I see something like the organization is a Palo Alto. So why I see this is not secure? It's because in my roots certificate, I'll show you in the Linux, I'll show you in the Windows. I'm much familiar with Windows on that. So inside your trusted store. So when you're troubleshooting your SSL, the primary thing is if it is your traffic is over the firewall, routers or switches, it can be anything. But what is the theory you should understand behind this, the working mechanism of it? So this is my source and this is my destination. Your connection happens, and this is an HTTPS connection. So when I say HTTPS, it requests for an HTTP request, HTTP GET request, and the server should send a HTTP for the GET. It should send a response, OK response, and your website opens. But since this is vulnerable, anybody can snip your traffic. We are doing HTTP over TLS. So we never know what kind of protocol is used, what is inside. If you understand your IPSec tunnel, that's pretty much the same because we are using the same key encryption hashing, both end. So in the beginning, when your connection establishment happens, it's going to exchange these three parameters, your key encryption hashing. The same thing happens with your TLS connection. I'll show you, even though it is encrypted, still you can see your key encryption and hashing values here, right? So that is something called as a cipher suite. So on the both end, they exchanges the cipher suite messages. This all happens on layer 7. So before this, what is the key thing you should know? Before going to SSL, some people, they do troubleshooting the SSL and they take a capture and they look for any packets. But if you see any kind of TCP reset, we discussed about that. We know who's doing a reset, how to find it in Wireshark. So do you see any TCP reset? No, I see a successful three-way handshake. And if I want to see anything related to the error, what I would suggest is always look for your record layer, the Wireshark. So here, let's see what is the error we get from this capture. If I go to Wireshark, so the three-way handshake, right? So we know this 4-tuple connection. So the source is coming from 4554452. It's a port number, randomly generated port number. It goes to 443, and 443 responds back to this. I say SYNAC. For the SYNAC, it acts back. This 30002 is the client. 30001 is a server in our example. Until this point, you don't see anything encryption or decryption happens. Your TLS kicks in after your three-way handshake. So here you go is your client hello. The client is not going to propose any kind of certificate. It is just trying to establish your connection. If you look at your record layer, this is very important. You have to look into your record layer and what is the TLS version it is using. It is using TLS version 1.1. And if you open up your HTTP protocol, sorry, when you open your handshake protocol, it's a client hello. What else you see? So it is proposing with the TLS version. That is very important. We have to go step by step. So here, when the proposal happens and the client proposes with TTL 1.2, this is a client. In the same scenario, we take 30002. This is a PC. It opens a connection with a firewall. It is a self-signed certificate that is 30001. When it opens a connection inside your client hello, example, the client supports only TLS 1.0, an example I am telling. But this particular certificate, what is created in the Palo Alto, right? So if it doesn't support your cipher suite and if it doesn't support your TLS 1.0, your connection is again broken. I'll try to come up with some kind of capture with that, with the broken TLS connection. So due to your TLS version mismatch, your connection may break. I would not say break. You can't establish your connection with your server. because of a TLS version mismatch. Here is this. What are the possibilities why I can't establish a connection? Or that why I can't delete this? Because the first thing, as I said, you have your successful three-way handshake, three-way successful. But the very first problem I have seen most of the server and client issue, it could be your TLS. So where do you find your TLS in the Wireshark? What is the proposal? You can see that right over here. And the protocol used, see, this both are talking to each other on TLS 1.2. That's the meaning of it. So let's go to the client hello. So TLS 1.2. So right now, we don't want to focus on random. So cipher suites, if I expand the cipher suites, so what does this ECDHE stands for? TLS, and it is using Diffie-Hellman key. So I said again, key encryption hash. And you can see this Diffie-Hellman key is used here. So it is proposing all the cipher suites. So the client in the client hello, it is proposing all the cipher suites. So based on this, on the server hello, we have to see what is the proposal and how it negotiated. And out of this 10 or 12, it has to pick one Diffie-Hellman key for an exchange. And we should know about what is this master secret password, pre-master secret password that is created. I'll tell you about that. For the very beginning, so when it proposes a client hello, it will send all its cipher suites. So I send 15 cipher suites from my client hello, and it's depend on the server how it responds back. And if the client doesn't have all this 15 and it can't match, your TLS connection will not happen. But at this point, it is just in proposal. I have to look for my server hello to see what exactly happens here. See, if you look at this, this is change cipher spec, and it is all encrypted until this point. Is this really important to understand all this? Yes. When you're troubleshooting this, if you go deeper, then you can find your problem very easily. So one thing I said, it can be a TLS. The other one is that your cipher suites. So we are exchanging 15 cipher suites, and this is the client hello. And if you look at this, this is a hashing algorithm it is used. If you expand this, SHA-256, SHA-384, SHA-512, same. Key encryption hash. So in this proposal, it is bit different. It uses your, so key, the key is Diffie-Hellman key, the encryption is AES. AES 256, AES 128, AES 256. So this is all the combination of your Diffie-Hellman key with your encryption. So that is bit different with your IPSec tunnel and TLS. So here your key. So the three parameters, or these three parameters are needed to establish your connection. Like your IPSec tunnel, you can compare. So the key is we are using a Diffie-Hellman key. The group is decided along with your encryption. Diffie-Hellman key plus your encryption, say for example, is AES 256. And hash, we have seen that is SHA hash. SHA 256 or SHA 512. So in the proposal, what else it's going to propose the client? So the client is proposing your TLS version, client is proposing your cipher suite, and along with that, it is proposing your Diffie-Hellman group, key encryption hash, and TLS version. And it doesn't support, it's going to break your connection. Right? So until this point, you have to go by packet to do your testing. Sorry, to do your troubleshooting. So once I see this is all hash algorithm. You see 11 algorithms here. So what is the response I get from this? This is just an acknowledgement for a packet, and this is my actual server hello. If I come down, so it picked this AES 256 algorithm, and this is the Diffie-Hellman group. And it is okay with version 1.2. So after this, everything is encrypted. So what is the meaning of this? So once you see a successful server hello, and if you see something wrong with this, you can't see your server hello happening. So if your server hello is happening successfully, you should see a message, change cipher spec. Inside your cipher spec, what else will happen? It will look for your TLS version, it will look for your encryption, it will also look for your hash. And you can see what exactly it's been renegotiated. What is that? This is the value it's used for your TLS. This is used for your Diffie-Hellman, and this is your encryption algorithm. After this, everything is encrypted. We can't see anything. So when you're troubleshooting this, you have to start from your layer 3. Is it my routing happening? Do you see the successful three-way handshake? What else I have to see in my client hello? It is proposing all the TLS parameters. Do I see my TLS version there, and is it matching? It establishes a connection. So until this point, I should see my server hello. After this, everything is encrypted. And if there is something problem with your, after this, if there is some kind of a redirect, you should still see your reset after this three-way handshake. Because right, if it is a redirect, it is not a direct connection to it. The backend database server or any server can be connected to that particular server. So from there, you have to apply your logic to figure out a problem. So yeah, once I see this client hello, server hello successfully happening, and after this, if there is a problem, I should see some kind of a reset packet. But here I don't see anything like that. So if I close this, so this is not a broken TLS connection. I see a successful connection. I don't see any kind of error in the record layer. See, in the record layer is your key. So here it says the change cipher spec protocol and change cipher spec. So here the proposal is happening. After this, everything is encrypted, and you don't see such kind of message in the record layer after the successful encryption. Same like you can compare your IPSec tunnel. So if I want to build this SSL tunnel between my source and destination, the key encryption hashing should match. And along with that, what we don't have in a VPN is a TLS version. So here is a TLS proposal. What kind of TLS version you are using it? If you're using some kind of deprecated version, and if the server doesn't support it, it's going to break your connection, SSL connection. And also it will always look for your highest TLS version. Sometimes it may have a TLS 1.2. It may propose. It is purely designed by an application, right? When you're troubleshooting a problem with that, if it goes with TLS 1.2, but whereas this guy supports TLS 1.3, and he proposes TLS 1.3 from the destination, and if this guy or maybe this source has TLS 1.3, it's going to talk to each other on TLS 1.3. But most of the applications are designed to use 1.2. Most of the time I have seen 1.2, and if you do see TLS 1.3, it's nothing wrong. All you should understand is it always look for your higher TLS version. It will not pick your lower version. And if it has a lower version and it doesn't have this higher version what the server has, then you can't establish your connection. So this is very key and primary to understand your TLS communication, and this is how you should see those values in the Wireshark to troubleshoot. So now going back here, so it is a bit of theory here. So hello message, the client and server exchange hello messages to negotiate security settings. Server authenticates and pre-master secret is created. I'll tell you what is that. The server sends a certificate to authenticate itself. The client generates a pre-master secret and encrypts it using its server public key, then sends it back to the server. So this is all from the theory standpoint. I'll explain this, but the primary focus of troubleshooting is something what we discussed that we should be aware of. So now let's see how the session key, all those things are created. So once this both the client and server sends a finished message indicating that the handshake is completed and secure communication can happen after that. So once the session is terminated and the session keys are discarded. In very optional phases, right? So generally what happens, who is proposing the certificate? What is public key and what is private key? That's something I'll tell you. So if you have created your CSR certificates to I would say the main ingredients to create your certificate that is used for SSL. What you are going to define, you will define your TLS version. Say, for example, you are going to create a CSR. That is certificate signing request. Before you get your TLS certificate, you have to do your CSR. It is just to prove that who you are. And this particular CA who is going to sign your CSR and he will give a key, right? This is a three-step process. So you create your CSR. What else you will look into your CSR example? I'll show you that example that helps better. Where is that? We went to QTLS. Conversation filter, TCP. Where is that? I can't see. Okay, this is a VPN internal traffic. This is the receive VPN. Where did we see that traffic for the SSL Linux one? Okay, I think we didn't capture. I think we had this capture, right? We were discussing about the capture missing here. Yeah, 30001, 30002. Okay. So can I see the TCP connection here? So this client hello, server hello, sends an act, yeah. We go to conversation filter, TCP. Yeah, I can see that. Client hello, server hello, TCP. I want to see an information there. Yeah. So if I go to this Wireshark, it is telling that connection is not secured. More information. View certificate. So from here, this is a self-signed certificate, as I said. So this is a common name. So what are all the key parameters when you create your CSR? So you should give your common name, and there is something called as a SAN name. So look at this here. The issuer is organizational unit is Palo Alto. So this is your CA. So who is the CA certificate authority? Who gave this certificate? This is given by self-signed certificate within the firewall. So that's why you see all this information. So whenever you create your CSR, you should fill up all this detail. This is how the certificate works, right? So you have to define your encryption, the whole thing. You have to define your when you're creating your CSR, it decides, right? So in your CSR, you have to define your what is that? What is the encryption you're going to use, right? The three parameters. I mean, your common name. Example, it is google.com. And some people they use what SAN name, that is subject alternate name. When you create your CSR, and what kind of encryption you're using, what is the hash you're using it. You will define all this encryption. Say for example, you're using AES hash you are using SHA 256. So subject alternate name. Example, youtube.google.com. So it is telling that I am going to use all these DNS names in my CSR, right? And along with that, which company you're from, what state is this? Example, it is, I'm just telling for California. An example I'm telling. Country, US. Organizational unit, what kind of organization? You are an IT status, North Carolina. So all these parameters you should fill it, and you should give this detail to the CA, certificate authority. In the self-signed certificate, that is why we get this certificate warning. Connection is not secured. Even though it is HTTPS, your computer is not trusting it just because I don't have this CA information, right? The CA here it is a Palo Alto. We should know this to troubleshoot. Sometimes we see this in the self-signed certificate. If you see connection issue, that could be the problem. And also, have you tried? Even I had this problem when you create something like google.com, and if you type 8.8.8.8, even though you have your certificate on your trusted store, if you have your certificate on your trusted store, you have a certificate of this CA certificate, Google CA certificate, root certificate of C, root certificate of Google. If you have a root certificate of your Google inside your Windows Trusted Store. It's not going to trust because I'm using an IP address, but I have to use a DNS because once you use a DNS, only then it's going to look inside your trusted store and do I know google.com? Do I have a certificate for it? There's a root. But because this CA now for the Palo Alto, this is the Palo Alto, this is the root certificate, self-signed certificate. The firewall itself signed the certificate for HTTPS connection, but my computer doesn't have the root CA of Palo Alto. My Windows computer is telling that I don't know who is Palo Alto. I can't trust this certificate. That is the warning you see there, right? But still, you can see your HTTPS connection is happening because you are doing an exception. This is not successful because you are doing an exception. If you are not doing it, your connection get broken. If you remove your exception, if you try to establish your connection, it's not going to work there. So now let's go back here. Let's go back to this Windows PC. All comes in one console. Okay. So here, I'll quickly fix this problem, the Wireshark here. It doesn't show up the interface here. Let's quickly download this. So I'll show you what exactly I did. It's a simple topology. Even you can try for your HTTPS traffics. So here you have to add a node in your EVNG, and I'm using this. You can choose your cloud option here, right? So what happens is it is directly connects to your broadband for your public IP address. And since if you know your public IP address, you can give statically. But I generally use a DHCP assignment in the VIOS. I mean, in the router, I'll show you how to do that. You can play around with your SSL connection with this. If you see, this is 122, 160, 50, 60, right? So I got this through DHCP. I didn't manually assign it. Show run interface GI0/0. Then I did a NATing. I did as a NAT outside. This is an outside interface NAT. This is my inside interface. Right? Say this is my NAT inside. This is your NAT outside. This is your NAT inside. So I have an ACL just to allow show run section access list. Access list 1 permit any traffic. If I give NAT configuration, show run. It's pretty simple. I'll show you how to do that. Show run section. NAT. So let me remove all this config and I'll show you how to establish your connection with this to get your access to internet. The control E doesn't work here. Priest. This priest waiting for it. So I'm going to remove this and I'll tell you how it works. What is the logic behind this? You want to delete all interface. Yes. Show IP interface brief. So this will take time, right? So I'm not going to delete this interface, right? So all you have to do is you have to do a right click network, choose your the cloud one, anything. So I did the same thing and you should have your router like this. You should connect that interface. So once the connection is done, see this is GI0/0. I'm going to this VIOS. Show run interface GI0/0. The configuration is I gave a NAT inside. I gave an IP address. Sorry, this is GI0/1, this site, LAN site, and this is outside. This is your inside, and this is your outside, and this is your NAT inside, and this is your NAT outside. And then you have to create your ACL, right? You have to define this everything inside this interface configuration. And in the ACL, I'm going to permit all the traffic. And this private IP cannot be routed back to the internet. So on this particular interface, this is an outside. I am doing a NAT on this. So what happens here? All this private IP is translated back to the public, and it's going to take this IP address, the public IP address on the router. That's a configuration exactly I did. So this is the inside interface here. NAT inside is the only configuration I did, and I picked 10.0.0.1 subnet for this. Copy paste this. Why is this happening? Can do a duplicate, right? So I picked 10 network here. It is 10.0.0.1 on the router, 10.0.0.2 here. This guy. I just made it as very flat network. So I am using 10.0.0.2. It's a layer. Sorry, it's a VLAN 1. Untagged traffic, so no VLAN communication. The other end on the switch here, I am going to do a trunk. Where is my switch? Just it's loading. So in the switch, if you see the configuration show run interface GI0/1, right? So I didn't do any configuration on GI0/1. It's purely untagged traffic, so I don't want to do a trunk on this. On GI0/0, show run interface. GI0/0. It's a very simple connection for my SSL testing. So I didn't do anything. So if I give show VLAN, all a default for this switch, and this is the interface that's connected to the PC. You can confirm or you can verify this by looking into this. Both your line status and protocol status both should be up and running. Your protocol is up, line is also up, connected. Go to this Windows computer. You maximize this. Go to internet setting. Go to change adapter. Double click. Properties. Go to your IPv4 configuration 10.0.0.2 all 255/24 we are using it. Gateway is 10.0.0.1 and we are using the DNS 8.8.8.8. So okay. And from here, once you do all the configuration to verify, you can open your prompt and you can try to ping your 8 network. Now it is not working because we don't have a NAT configuration here. Go to VIOS, show IP interface brief, exclude unassigned, show run interface. Because we are not doing NAT overloading, right? So your NAT translation is not happening. Ten zero zero one show run section NAT. So I don't have a overload statement. So if I give show IP NAT translation, I don't see any translation because I don't have a rule for it. So I have to quickly create a rule. So I have to create an access list, IP access list 1 standard. Standard 1. I'm going to permit all the traffic, permit any, and I'm going to create a NAT, IP NAT inside source list. I have to define my ACL number 1. Then I'm going to do an overload. I'm overloading all this traffic to one specific interface, that is my outside, that is GI0/0. Overload statement, it overloads all my traffic to this. So all the private address comes and hits this GI0/0, and it goes out as a public IP address. That's the meaning of it. So we are overloading it. Irrespective of how many hits it gets, it's overloaded to a public IP address. So if I give show IP NAT translation, now I can see the traffic. I can go to my Windows computer, and if I try to ping it, I can ping it. Now the translation is happening. Once I do that, I can go to this Windows PC and I should download my Wireshark and I should see that. For that, let's go to the website. I think this is a pretty old image, what I'm using here. If I go to your Windows system, Windows administrative tools, and if I look for system information, and this is a 36-bit operating system, sorry, 34-bit operating system. So it doesn't support the latest Wireshark. So I have to go for the older version with 32-bit. You can use if you are using 64-bit, no problem at all. You can straight away go ahead and download the 32-bit version. Let's try this. Yeah. We will install, uninstall. Reset control panel. Go to control panel. How to uninstall that? If I do an uninstall, it's an existing. I don't want this. It's not working, so I'm going to remove this. Hopefully this should work. Let's see. It's a pretty big file. So in the meantime, okay, we need a Wireshark to see this capture. So let's go back here. So we are almost done. Maybe in 3 classes we'll be finishing everything. We troubleshooted the IPSec issues. Then we are on SSL now. Certificate validation encryption. Then we are doing some kind of troubleshooting with that. Then we are finishing the SSL. Actually, I tried this, but I don't know that this particular Wireshark should have a problem. It's some developer version there. So when you're choosing your operating system here, I think you have to, the Linux is a bit difficult. For this particular capture, if you are using Linux, the encryption and decryption profile is a bit different for that. So I'll walk you through until the downloading happens, right? So we got one more thing to discuss. Let me quickly open that. Let me open the document for you guys to show you the encryption and decryption profile, how to do the step by step. In my Wireshark, I'll show you that. So you have to go to edit. I'll tell you how this encryption decryption works first. Then you will get better understanding about that. We'll continue that in the next class. But the SSL encryption and decryption profile, right? So here, in the client, hello, it sends server hello again. So after this, everything is encrypted. At this phase, it creates a session key. And also the client creates a pre-master secret. So this pre-master secret once the client creates, right? So when you open a web browser, the whole point is when you try to visit a website, it creates a pre-master secret. So using a profile setting, we are going to capture this pre-master secret and we are going to add this in your Wireshark profile. So once you add it, there are two options. One is your pre-master secret. I'm sorry for that, it's not SSH. You should understand this how it works. Yeah. So this is pre-master secret you have to add. Along with that, you should add your SSL debug logs. So once we create, this is all encrypted. So once you capture this pre-master secret, this particular profile, what happens for every time when you visit a website, and I am telling this is purely for an educational purpose, right? When we are doing it, so get a proper approval from your management and do that. Yeah. because we are capturing the pre-master secret, and once it is encrypted, we can't see anything. But with the help of pre-master secret, for every session it goes out from your web browser, it's going to capture the pre-master secret for every session. Example, you're going to google.com, you're going to yahoo.com. So it's going to store all your pre-master secret in your SSL log file. I'll show you how to create it. So once we save this, even though it is encrypted with the pre-master secret, you can decrypt all your traffic and you can see what is happening inside. Something like, is it what kind of HTTP protocol is it using, or it is using some kind of DNS over HTTP. Sorry, DNS over HTTPS. So for that, how do I create a profile in Wireshark for it? So you have to go to your Wireshark in Windows. Before that, you have to set up your environment variable. That's something I'll show you how to do it here. It's done. Okay, let it run. So in the meantime, here, if you go to Windows Administrative Tool, and if you go to Windows System, Windows Administrative Tools, and if you go to Computer Management, I mean, in your Windows, it is pretty much simple. I think it's a straightforward system configuration. Sorry for that. Actually, where do we do? It's right click on your PC, properties, go to advanced system setting, go to environment variable. Here you have to define a path. Example, it is a SSL key lock. You can give any name, SSL key lock. And here you have to actually give your path. Example, if I'm giving a path for the admin, just for now, I'm giving a path as an admin. I want to click OK on this. So I have to create this environment variable, go to this user variable for admins and create an SSL key lock and give your directory. So once you do this, go back to Windows C, users, admin, create the same name, whatever you have created there. Right click properties, advanced systems, environment, edit. I'm going to copy this name. Going back to this PC, going to user, admin, create a new text document, give this name, enter. For the debug log file, the same. If you want to keep it the same debug log file also here, you can keep it here. Create a document, debug underscore TLS. So once you do that, come back to your Wireshark profiles. Go to your Wireshark. Capture your Ethernet traffic. Make it little bigger here. Okay, stop this. Edit preferences. go to your protocols, go to your TLS. So here you have to define your pre-master secret. You have to go to your PC, double click, user, admin, come to this key log file. You have to be very careful when you're choosing this. Go to debug, select debug. Yes, replace it. Pre-master secret key is the only place here you have to do it. Click OK. That's it. So once you do that, you should see all your decrypted traffic. That's something we can do it in the next class. So all the two things you have to do, you have to create your key file. You have to go to your environment, and as I've shown you, you have to define your variables, and then you have to define your debug log file. Then you should attach to it. As I said, you can see this quick protocol. It's fine. That's not related to this topic now. So let me do TLS. Right click, conversation filter TCP. I should see something from the beginning. Client hello. This is the other capture. If you see this in the client hello, we are using TLS 1.3. I told you, right? So it depends on the application. So here, what is this 104? Let me check that. Let me try to minimize this. Try to NS lookup. I have seen people, they don't understand I mean, not everyone, I am telling. There are people, they don't know how this TLS negotiation happens. They do see that, right? So with this, DNS can't find 104 non-existing domain 104.26.0.63. Why it is not doing it? So DNS NS lookup 104. Can I ping this guy? Ping 104 dot 26 dot 0 dot 63. I can ping it. But if I do a name resolution, why it is not happening here? I just want to see what is that destination. Okay, let's leave this. I mean, let's go back to this TLS. So here, if you look at this client exchange TLS 1.0, right? But if you see this protocol here, it is 1.3. In the server hello, let's see. It says it's 1.2. The exchange here in the record layer, if you see, that is TLS 1.3. So the exchange is actually happening, the whole conversation is happening on TLS 1.3. You can see your record layer always. So it is using the highest version. So this is how you should figure out what is the TLS version exactly used for this particular conversation. Go back all the way back here. So look at here, it says we saw this client 1.1, see 1.1 exchange, but your actual record layer, it shows it's 1.3. So always look for your record layer to see your TLS related detail, your TLS error and everything. Always keep an eye on your record layer. So here the whole conversation, if you look at this, even though you see multiple TLS versions there, if you want to see this capture and if you want to know what what is the exact TLS version it's used for this exchange. It is TLS 1.3. Always the highest version is used, irrespective of whatever the exchange happens. It always picks the highest version. So the client and the server, it both supports TLS 1.3. So that's it for today. Tomorrow we will see how this encryption decryption happens and how do we troubleshoot that with the logs and some use cases. So now I'll give an unmute permission. You can ask your questions. Do you guys have any questions related to the topic what we discussed now?
Yeah, hi, Praveen.
Yes, Meeraj.
Yeah. So here it is showing 1.3, also 1.2. So they both supported 1.3 and 1.2, or one side 1.2, other side 1.3.
No, that's what I said. Both are exchanging different TLS version, but it agreed upon 1.3. Yeah, the exchange happens like that. It proposes, but it picks the highest version. So both agreed on 1.3.
Okay, so like for example, we are accessing the Office application, and that is on the load balancer.
Okay.
So how will be the communication related to the master key and the session key?
No, that is totally different. That is for encryption and decryption, Meeraj. That is not
Yeah, yeah.
related
So
to the
if I want to see the traffic between the client and the Office application, and if I want to decrypt that one, so how it will be?
next class we will discuss this in detail. I'll show you how to do this decryption with that pre-master secret and all this details what we discussed now. I just shown you how to create a profile, but I didn't do the decryption now.
Okay.
Yeah, the tomorrow's class we will discuss the decryption.
Mm-hmm.
There I will cover your pre-master secret. And what about Malhar, Prashant, and Juan?
No question for that.
You're good, Prashant. You don't have any questions.
No
Specifically,
problem.
we
Only
meet.
one thing, that cyber okay, you showed like 15 cyber here, right? So
Mhm.
that should be match or that should be different in the both the location, right?
No, no. The on based on the 15 cipher suites, it's going to pick any one.
Okay, means yeah, correct. Okay.
Yeah. Okay, Tuan. What about Miraj? Okay, Malhar. You have any questions, Malhar?
No problem, I'm good.
Okay. How about the labs? You guys are doing the labs? How it is going? Just to know. I mean, it's just a casual discussion. Is it how your labs are going? You guys are practicing it, or you guys have a work engaged with work and you didn't get a time to do your labs? Prashant, Meeraj, Malhar, Tuan. Just to know. I mean.
I'm doing on like on the live troubleshooting
Okay.
uh, related to my office. So
Okay.
I'm seeing everything
Mm-hmm.
this one.
Okay. And
Yeah.
how about your troubleshooting? Is it something you can try something new in Wireshark or something additional information now you can actually grab from Wireshark than
Yeah,
before?
now I'm able to understand, like I have a client server troubleshooting.
Mm-hmm.
So one, I found that the SYNC there was a routing issue.
Mm-hmm. Okay.
I able to find, and the second thing is the MAC address from the firewall into the router. I receive a
Mm-hmm.
packet
Okay.
and I send the packet, so I able to find out that it is properly receiving and sending. Just to
Mm-hmm.
see, because I have a two outbound routing. So
Okay.
is it receiving from one and sending to one, that I need to see. So I was able to easily find it out that after your classes.
Okay. Okay. And one more information, Meeraj. When I asked a question about this over the IPSec tunnel, if you see your TTL, it will not show your TTL that's being decremented all the way back to the destination. It will just think that it is directly connected, and all you will see is maybe TTL of one most of the time
Yes, yes.
because it is a site-to-site tunnel. It just
Mhm.
thinks that they are directly connected. They are on the same network. That's the whole point of doing that. So when it comes to the tunnel, you have to differentiate your tunnel values there. Mostly it would
Mhm.
be the decrement of one because it is just crossing one network.
Mhm.
Yeah, that's just an for an information for everyone. When you're capturing your VPN, your TTL would be one. In my testing, it was like that. I don't know about other vendor, but logic is like that. So over the tunnel, your
Mhm.
communication is happening, right? So your
Yeah, yeah.
traffic is routed like that. It's just one hop between these two networks. That are just separated by one hop that's between this different LAN network.
Mhm. And for the cyber, I mean, like the cipher, if the cipher didn't match, then it will not establish the connection,
You
right?
will not receive your server hello because the client first
Because
initiated traffic with server, so it sends a cipher suite. And if you don't find it, you will see something with your record layer.
yeah, that is correct. Yeah, for TLS that is correct. But for the cyber suite, normally all the latest browsers supported all the cyber suites. And from the like mainly our connection terminate
Yeah,
on
that is actually
load balancer.
a good thing and added information. There is a place exactly we can see those cipher suite exchange happens when I was learning about this. I saw that. That's actually a good thing. I mean, there is a place where the exact negotiation happens, right? You can
Mhm.
see your cipher suites, what is exchanged by the browser for that particular connection. I'll just try to remember that and I'll tell you in the next class for sure. I remember that for sure I have seen that when I was learning about this. There is a place you, we can actually see the cipher suites what is being exchanged here. This is extension version. This is related to certificates. There is a place in the browser we can see all the cipher suites you're talking about, right? The
Yeah, yeah.
cipher suites we can
So
see what are the cipher suites
yeah, yeah.
about. But anyway, in the Wireshark, whatever you see, that is exactly the browser is sharing those cipher suites because we are capturing the TLS traffic over this TLS. Instead of a browser logs, we are capturing that from Wireshark. The same client, whatever the cipher suites the client is trying to propose, you are looking those cipher suites inside the Wireshark. Yeah, yeah, you
Yeah.
said
So
something. Yeah.
yeah, yeah. I just want to tell something about this one.
Mm-hmm.
So
Yeah.
normally what happened, all the browsers supported the latest cipher,
Mm-hmm.
and we also configure on the load balancer the
Mm. Yeah,
cipher
yeah,
in the
yeah, yeah,
client.
yeah. Yeah, load balancer, we have an
So
option. Yeah.
like we receive the configuration from the cybersecurity side that
Mm-hmm.
only enable the high security cipher.
Yeah, yeah,
Okay.
correct. You're right. Yeah,
So
only the
in
highest.
that,
Yeah.
yeah, in that case, the client, the browser, and the application can able to select the high security server and they can
Correct.
connect.
Correct.
But the
Correct.
problem, what I notice,
Mm-hmm.
like the integration team, normally they
Okay.
use tools
Mm-hmm.
like the Postman or some other kind of tools. So
Mm-hmm.
normally they connect through tools and they
Okay.
just have, limited like low
Options to
service
change the
yeah,
parameters.
and low TLS. In that case, they have the issue connecting to the application. And
Awesome,
they will
awesome.
say
So
that
you
this is
found the
the
problem. You found the
yeah,
problem.
they said that this is a network issue.
Mm-hmm. How did you find it? I mean, it would be helpful for everyone. You can share
Yeah.
your troubleshooting. Yeah.
I'm just telling you that the browser-based client they are able to connect, but the integration teams they are not able to connect, and they will say that there is a load balancer issue or there is a network issue.
No, I got
So
it. But how did you find this is a TLS mismatch? How did you find it? In the Wireshark
yeah,
or where you found?
so now we have a latest load balancer which is from the AVI network.
Okay.
AVI network is mainly it is supported on the virtual environment, like they are moving to cloud also.
Okay.
So they have a very good visibility on the layer 7, the logs.
Okay.
Directly you can see on the load balancer itself. So what is happening on the layer 7. So if you can even see the header also. You just click the header, you will see header received from the client and sent to server.
Something
All
like
those.
Wireshark log.
Yeah, something like that. So there you can see that the cipher is not matching.
Okay.
But it is good also we can able to show them on the Wireshark also. If there is a connection broken for those kind of tools when they are communicating to the load balancer, so we can show them in the Wireshark that the connection is low because you are not using the high security ciphers.
Okay. How about this level of information you get? I mean, the level of information what you get in Wireshark for the cipher suite exchange and TLS. Do you get the same kind of logs in your load balancer?
For the ciphers suites, it is there easily you can select. It's like a checkbox from the
But
load balancer.
how intuitive it is? It is like Wireshark where you can spot your issues quickly, or how is it? How do you feel about that? Just
Yeah, you
generally.
can. Yes, you can able to like if the connection is broken like in Wireshark due to SSL, you can easily find there is a log that SSL handshake not done, something like.
What about the unknown records on all those errors we get sometimes? Unknown CA errors. Are you able to
Yes,
see those kind of things in the
yeah.
load
Unknown
balancer?
certificate, you will see unknown certificate.
When you compare your Wireshark with that load balancer logs, which is better from your standpoint?
Wireshark is of course better,
Okay.
but there you will find some information.
Okay. For
Yeah.
load balancer, that's fine, but for firewall or something else, we can't figure out, yeah?
Yeah, definitely.
Okay. No, just to compare, I mean, how is this Wireshark stands
No,
out from
Wireshark you
that?
will find each and every detail.
Okay.
Like we can able to find it out layer 2 connection issue, layer 4
Yeah.
issue.
I would, yeah, you should, I stand with you for that. Yeah. I don't know whether we can see the layer 2 problems, right? Most of the time, if you see, there is a problem with that. Even I have seen there is some routing issues. We saw with just with this VLANs, right? So why my default route is going to VLAN 135 but not 125? So just
Yeah,
by looking into this Wireshark logs, we found why do we see this VLAN here? Because this VLAN is not related. Because if my traffic has to go from one single interface, but in the logs you can't spot that. I mean, it won't spark very. How do you say that? It won't spark at that particular moment. I mean, it takes some time for you. But in the Wireshark, I have seen that scenarios. I mean, if it is a VLAN mismatch or if it is a wrong gateway it's being used for routing, it helped for me to find.
yeah.
Okay, yeah, nice. So you guys also come up with some kind of troubleshooting experience that would help everyone. We can share information and grow together. Yeah. Okay, so that's it from my end. We'll catch up in the next class. Yeah.
Yeah, thank you very much,
Yeah.
brother.
Bye, everyone. Bye.
Thank you.
Thank you. Bye.